our different types of knives, just like for the food, you can kind of correlate like our materials that we're using now. Back in the day, all we did was paper dyes. Paper dyes is like butter. Easy stuff. Because we would make the blade angle all the same. Traditionally, it was always hand tooled, okay? They leave a little small flat on top of the blade, which they used to call the salt and pepper look. The salt and pepper look is at the very top. If you look under the scope, it looks like little sharp spots, not sharp. It has a salt and pepper kind of look to it. That's how a tooler determined that, okay, it's sharp. Then he would take his finish tool and just clean it up to make it nice and smooth, okay? Then we applied chrome to it. Chrome serves three purposes, all right, for the blade. It serves the purpose of life. It gives it life because it's like a turtle shell. It puts it up, wraps around the blade to where that it holds that and makes that blade tougher, okay? So there's less resistance. Then you got another purpose is for oxidation, when heat treating, when the carbon gets pulled out of the steel, it goes into the chrome. We strip the chrome off, therefore it's not black as night, okay? And then the third purpose, chrome, it's beautiful. It's shiny, it looks good, you know? Can't beat the chrome. Okay, so what it is, that was how things always went, and that's how you got this little butter knife, because it just lasts for millions of revolution and lasts a long time for the customer. Now the customer is throwing out the filet mignons. It's coming out with material that is much more difficult, static vinyl, stretchy, polyethylene, stretchy, nasty stuff. So you need a steak knife. You need something keen to be able to slice through that material. But the keener the blade angle, the less die life you will have on a tool, because it's not going to hold its sharp edge. You don't want to put chrome on the real difficult materials. The whole reason for it is because chrome, like I said, is like a turtle shell. It case hardens, it puts that beautiful shine on the blade, but it also is attracted to sharp edges. So it's like a little ball on top of the cutting edge, which is not going to cut very successfully at all, if any, on the most difficult materials, okay? Then you have your cellular phone material. The cell phone, you got light, you got everything to where that you need different types of blade angle to be able to cut it so it's straight up and down, so that the light doesn't beam off somewhere else on your cell phone. So that's what we have, a beaver tooth is what we call it, which is basically straight up and down and then tapers off. With the beaver tooth, we want to be able to make the cutting edge, which is a beveled edge, which I will draw. And what that does is you cannot have that beveled edge too large, or you've just made a regular blade and it's not going to cut and have a straight flat on the material, okay? So, where do we begin? Where do we begin? We begin with a foundation. The foundation that we make, okay, is a tapered angle. Look at a knife. A knife is tapered, okay? A knife to be able to cut, and then it splits, okay? Disperse, all right? So we need this foundation to be created. But then we engrave it to create the foundation. But then what we need to do is we need to be able to not distort the shape, or the customer is going to be pissed. hey, I want a 1 inch by 1 inch rectangle. I don't want a 1 inch by 10,000s and so on, you know, in different directions. And what happens is that during the heat treating process, the shape changes, it grows, it shrinks, it warps, it distorts, so where that it's out of whack. Therefore, we got to go back and remachine the foundation to make it so that we got the established foundation, which will be then on sides, okay? That process we call CDC. Carbide distortion correction is what CDC means, okay? So we go back, we remachine the blades to be able to get this. Then we come back, and traditionally, you have the toolers, the hand sharpener, where they would take it and they would just scrape this side, then come scraping this side to get that cutting edge right up top. And what they look at the top of the blade, and like I said, they call it like a salt and pepper look. To where that, when you have the blade, it's like little speckles. That's how they know they got it to where they have it thin enough to where it's not low, because if they cross center, they're going to take the blade low, therefore it's not going to cut properly, all right? So they go for that salt and pepper look, then they'll clean it up with a finish tool to make it a nice slick top, all right? That's not sharp, or not, excuse me, it's sharp, but it's not crossing center. It just blends in that edge. We machine sharpen, and we do exactly what the toolers do, and we leave a small flat because we have a camera that's blown up to be able to tell how many microns flat do we leave on top of the blade. Typically 10 microns, okay? 10 microns is basically a 4/10 thickness. 339, okay? That's great on a lot of applications, but the most difficult applications, we cross center. We have to, because we got to make it as keen as possible. We cannot have a flat on top of the blade. Those are those really nasty materials, okay? So we intentionally cross center, which brings your blade down. Therefore, we need to grind off the bears. But the way we have things set up, we have a before sharpening diff and an after diff. Before, we always put less diff in the die if this is our target, so that when we do cross center, we're going to hit this mark up here, which is going to go below but be the appropriate diff, is the ideal thing. Crossing center is a pain in the butt. Pain in the butt because you introduce yourself to burr. Burr is our worst enemy on blade angles, okay? The reason the burr is because the burr will cut. It's deceiving. But the burr is ready to just fall off. It's like a hanging limb that you just get pushed back and forth, and that thing is ready to fall. That's where we look at it. We run extra passes to be able to make sure we try to control that burr as best that we can when we cross center, okay? So that's what that deal is. All right, blade angles. Telling you this is pretty much the gist of it, meaning why we need to cross center, where we would leave a thickness on top of the blade to be able to cut whatever the types of materials we have. we have different blade angles for different operations. The A blade angle, the B, the C, etc., is depending on the material and what the application is, okay? Like I said, for the cellular phone application is what we call a beaver tooth, okay? It's straight up and down with a tapered edge, and the very tip, if I blow this up, you got the straight blade, then you got the sharpening to where that you have a little bevel. That's what I'm talking about. One side, two sides, just to cut through the material, but yet this is very less so that the material will then fall in, keeping this straight. Their material, what it's going to be, needs to be straight up and down, all right? Booklet application sometimes uses this process, but we pretty much got rid of that because we found out that doing a thinner blade profile, which is your A blade angle, which makes the foundation thinner. Like I said, we start off thick. We start off thick because we got to account for distortion. An A blade angle, typically when we leave it thick, then we come by, thin the blade down, but we're forming a house effect where we come in with a different angle, 25 degrees. Our standard engraving ranges from 5 degrees to 10 degrees taper. This is not included. Included, it would be 20 degrees and 10 degrees. Reason we go off of that is what kind of tooling, what tools we make will provide the blade angle, that's the foundation that's going to be created, okay? Then we come in with a 25 degree tool to form this house, to make this thinner to where that now we're able to sharpen the top. Typically our standard is 74 degree, which is total 37 degrees taper. What question you got? Say it.
When do we determine that it needs to get a bevel angle?
Okay. So on this, we got this bevel. They use this die, and the die's not working on the material that they got. Okay. It'll be a complaint.
Okay.
But we should have caught it before going out, being a complaint. Reason being is, like, if we make this blade angle for the cellular phone, it will work. But it's not going to work in the customer's application because it's going to direct the lighting all over the place. That's why we would need to determine, hey, it needs to be straight up and down, okay? We, production, determine the blade angles, okay? Your customers are gonna learn from when you order dies, hey, this die isn't working, what are you gonna do different? Evaluation, well, we need to change the blade angle to fit it to your application. And then they're gonna wanna know, well, what is it? Because when I reorder, I wanna make sure I get the die right the first time, not the second or third time. So they start learning the different types of angles from us, from our competitors. Just going, oh yeah, I need a keen blade. What's your keen blade? Or here's what I want, okay, uniquely. Walco's a big customer that does that, okay, determines what blade they want, all right. We have different applications that I could tell you about what A, B, C, and all that stuff is, okay? The thing that I want you to know is that if you're not sure what is required, mainly because the customer is asking, ask us, ask Tom, ask Katie, because they are the ones that are gonna know what the material is. They're gonna know how difficult the material is. So we put the appropriate cutting blade angle on it, okay? That is usually given because just over time, we've learned that we build up a material base that has the appropriate angles that are applied to it. But there's always gonna be something new. And something new where come in and going, can we cut stainless steel plates or whatever? Absolutely. But you need a beveled, a blunt angle in order to do that. And we make changes all the time. Changes such as 3M, Texas does a, thank you, retro reflective material. That's your license plate material, the sticker. That's retro reflective. That's glass. That glass is gonna eat and munch up the blade, very rapidly. So we make it blunt, very blunt, like a butter knife. A butter knife that we just pound right into it. That's the key secret on how to deal with retro reflective. If you're not familiar with materials, that's where you go to, again, Tom and Katie, and bring it up. And if they don't know, they'll come talk to me, they'll talk to Paul, whatever. People that have been around that pretty much know what material it's gonna be and what's gonna be the application. So what I want you to get out of it is this. We gotta create a foundation. The foundation is in our engraved blade, the foundation of what the blade knife is going to be cutting, okay? Standard. Wilson standards, 10 degree, 20 degree included. When I say 10 degree, I'm talking about that's the tools that we make that have a 10 degree beveled edge. So when it cuts, it's gonna do 10 degrees here, 10 degrees there, 20 degree included. That's Wilson standard. Bigger the die, the more distortion is gonna happen through the heat treating process. Therefore, we need to combat that distortion. And how we do that, we then do our Wilson standard, we change it and we cut it in half. We use a 5 degree taper, which then this will be a 10 degree included. It's basically almost just straight up and down. So when it heat treats and distorts and then warps and then gets changed, shrink or grow, we got to keep that center line of that blade on the money, because when it does that distortion, it may put that center line over here. So we need a thicker foundation to be able to mold it into the cutting blade, the knife blade that we need to be able to make it work. Clear? Standard sharpening is 74 degrees. That's included. 74 degree, which in turn is a 37 degree taper tool to be able to establish this profile. Standard, 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 and then a 10 micron flat is standard. We don't cross center. We give the salt and pepper look, if you will. That way it doesn't go below center, but it's thin enough that it can handle probably about 85% of all our materials. But then you got that 15% material that just keeps coming back over and over again. Therefore, we have different blade profiles to be able to handle those kind of applications, okay? Which is not standard. Paper dies, it's like a butter knife. We use 90 degrees on those, a blunt angle, okay? Blunter, the better it will last, especially when you apply chrome on it. Keener the blade to be able to slice on the stretchy and the ugly materials. You don't want chrome because you don't want to dull that cutting edge, and you need that cutting edge to be thin and sharp. I mean, dead sharp. Sharp to where that you're gonna cut your finger, okay? That's how bad you want it. But our obstacles that we gotta make sure that we gotta run extra passes to make sure that it is sharp and controlled, because our enemy in this industry is burr. Absolutely, burr. Burr's a bad thing, awful thing, causes problems. Any questions? Did I lose anybody?
We need to come to you every time we have these questions, or is this documented somewhere?
Yeah, I just now videotaping it.
For each angle.
Huh?
For each angle that we provide, is there something in the knowledge base or anything?
No, there isn't, but I will. I will put it in a knowledge base. But here's the thing, these are our different blade angles. I can read it real quick if you like.
Can you read
I'm going to A, C, E, F, M, P, Q, S, T, V, W, Z. That's all our different types of blade angles, other than 50 degrees, 60 degrees, 74 degrees, and 90 degrees. 74 W. I said W. Okay. I will put that on this list on there. But I want you to understand, the customer's not gonna get, if you tell them, oh, it's a 74 W blade angle, they go, okay, great. The fuck does that mean, you know? But I don't want them to determine and pick their blade angle, but I will use it on the knowledge base, just in case if you come across it and you look to see if there's any kind of investigation, meaning that, man, my die, it worked, but it went dull real quick. Die life issues. You're gonna hear as a salesperson, die life issues. They're not gonna be happy, okay? But then again, you're cutting static vinyl. Static vinyl stretchy. It's not gonna last forever, you know, on the blade. It's gonna wear. That's more use on it. What other questions? Did I lose anybody? Elaborate.
Saying that basically these angles that we developed over the years are proprietary to us, developing them over time from trials and tribulations to give the customer. So we don't, this kind of establishes our product in a way of what kind of angles we can produce. So you don't really want to give that information away, because sometimes we always hear the angle called out as 60, 50, 74, but then you put the letters behind it, not only is it just a sharpening angle, but also determines how we manufacture that die, right? That's where all that
Exactly.
So sometimes you focus more on the sharpening edge, but the reality is there's a lot more manufacturing that determines the foundation to go with the
Absolutely.
edge, right?
Yep. Because bottom line, what Jack's talking about is that the letters that we chose represents a procedure from standard, okay? I'm gonna make the blade standard, but then I'm going to apply special procedures, whether it's in manufacturing or in a sharpening process, the blade angle that's gonna work for that particular material for that customer. Okay, so that's the part that this is something that I created to make it a procedural thing, so it's set in there that everybody in their department knows what to do and how to engrave it.
Which just gonna set us apart from our competition because these are angles that we've created. We don't know necessarily exactly.
Correct.
Maybe some of the stuff that they offer versus what we offer.
Our biggest competitor is Rotometrics, all right? They're the number one, and we're right there, right behind them and so on. So it's been that way, and I'm just talking about, I believe we make a lot better sharpened die than Rotometrics ever does. We are actually the pioneers of successful machine sharpening dies. Now everybody is in it, but I believe we are the best at it.
And we have
Okay.
some with D2 too, like another claim to that.
Huh?
Machine sharpening tool steel. There's another claim to that too, right? After
Correct.
we got past the first machine sharpening, then we developed into tool steel machine sharpening.
Yes. Yes. Rotometrics standard, 14.5-degree blade angle is the foundation that they use, okay? At 45 thousandths engraving depth. That's Roto standard. Our standard before machine sharpening, 15-degree and 50D is standard, okay? It's the same thing, but we have that little extra more give with the rounding up on a degree, whatever. This is standard before machine sharpening. Machine sharpening, we can make our dies exactly like FCS, meaning it's a sheet. The thickness of the sheet is what, 19 thousandths thick total? Okay, we can engrave 19 thousandths deep. But because of tradition, in the conventional way, customers, we actually did engrave it shallow at the very beginning because it was like, why not? And the customer hated it. He was like, what is this? This die will never work. And so we go, okay, let's not tamper. We don't want to piss anybody off. Therefore, we've always maintained a standard. But to combat heat treat and to oblige CDC, standard is now 10 degrees. But 50 deep is still the same, just because cosmetically and visually the customer sees it and goes, oh, okay, this is how a die always looks like. Doesn't have to be, but we don't tamper with it because we already been rejected from the past that it was made too shallow.
Is there any reason why we would want to do a weird shallowy? Is there anything that it would be good for?
Absolutely. The weird shallowy thing, our minimum space standard is 46 thousandths. That's in the database. 46 thousandths is the minimum space between two blades. Okay? But now you have a lot of customers, especially international customers with metric, they want a millimeter space. Then you got other projects to where that they want, oh, can we do a 35,000 space? Absolutely, but it's got to get approved. And to answer your question is, in order for me to successfully have a tapered cutting blade angle with this kind of spacing, I have to shallow engrave this area in order to accomplish that, okay? I can't go 50 thousandths deep to create a 35 thousand space. Actually, I can, but what I'm saying is that it's gonna be asymmetrical. It's gonna be a beaver tooth. Well, that beaver tooth is probably not a good application for that particular customer, depending on what the material is cutting. Big thing is Walco, in your case. They have the most ridiculous smallest space to cut a 3-layer with foam in it, thick material. That ties our hand behind our back in the sense that, well, we gotta go as deep as we can. I can tell you, he hates it because he's the one that's manufacturing the blades, and the thinner the blade, the tools that we gotta use are gotta be smaller, and the smaller the tool, snap, 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 they just break off, okay? But that's when we do typically apply, if you want that space comfortably, we need to shallow engrave, not make the blade height as tall. Any other?
Do we have a true minimum, or do you just?
A true minimum, I'll tell you the smallest space I've ever done, 32 thousandths. Okay, but that application was, depending what the shape is, it only had certain areas. If it's all lineals, doing this, okay, I could probably accomplish that and more because I could use a thinner bit and create the lineal blades on the lathe, not milling, okay? I could create the little squares, and then sharpening would then be able to create the bevel. But I'm only gonna be going down approximately about 10 thousandths deep at tops. So that material can't exceed 10 thousandths deep, or then it's not gonna work. So there's different cases, okay? If I had a bunch of shapes, like we just got done with Myers. Yeah, we remember this guy, don't we? Absolutely. Anyway. These spaces here are, the customer wanted, we wound up making them 45 thousandths width is what they wanted. So 1 thousandths below standard. Okay, not nice, we can do it. But if I had to make that 32 thousandths, one shape, I could live with it because I can fight these areas and make it work out. But if we did the die that we just got done doing, which is like 20 across and 30 around, that's too much. You know, too much meaning that the time for us to get it would be a week, you know, of just sharpening, you know, to try to get it, because that tool is not gonna last and it's gonna break off, and we gotta try to clean it up, and hopefully when the tool breaks, it doesn't extend or wipe the blade out at that time. So is it worth it? Valuable? Pass? Or hey, we need to try to open up these tight areas? What else?
Me?
Yeah. Hola.
Hola. I'm gonna ask you just, I don't know, this is weird. So there's a customer, they're always asking, well, we have on QC notes, it's a thermal transfer material.
Mm-hmm.
And even though it's supposed to be 74 degrees, they always ask for a 90
Yes.
because it's gonna last longer.
Yes.
right? So can they go like, the application you said is also
Mhm.
important.
The material, you can cut that material with a 90-degree blade angle, no problem. What kind of adhesive do you have that's applied on that material? If that material is so aggressive with that adhesive, that 90 is like an axe, because it's gonna cut and it spreads the material. It bursts the material is what it's actually doing. Well, you can't do that with ooze, with adhesive. And if it's so aggressive, you need a keener blade angle to be able to slice through it, to where now you're dealing with the die life of it, just because of the adhesive. If they had just normal, if there's ever such a thing, normal adhesive and not be a hot melt or something that's so aggressive and gooey, then I would say 90 degrees all day. Put chrome on that, be a butter knife, easy peasy. But because of that adhesive, you have to have less chrome for longevity, but then it's gotta be a keener blade angle to be able to slice it. So you're in a catch-22. You could give them to where it does die life, but you're gonna get adhesive ooze everywhere. It's not gonna be clean. So now you lost. You can't have clean and life at the same time, is what I'm getting at. Yes.
When you bring the order, sometimes automatically it says that it changed from 74E to 74W. What would be like the difference that the system automatically is like changing?
Okay. 74E is a beaver tooth blade angle, okay? And the reason it's getting overwritten, because we've learned that that 74E can be replaced with a 74W, which is kind of our Wilson standard. I keep saying standard because I'm the one that actually did that, sorry. But the reason being is because I want to try to have a procedure to where that it can handle 95% of all dies and goes out the door one time, not back and forth between departments. Back and forth, meaning that, oh, okay, well, they left the operators left the blade, the micron flat too thick, so now it's not gonna cut as good, or they have it so sharp, but they didn't control the burr. The 74W kind of is a procedure in sharpening to where that it is a 74-degree blade angle, but we chase it with a 90, which controls the burr quicker. And we found that that works better for that particular material. Okay, that's why it changed. We were probably trying to fight something for the customer, and we actually have a better way of doing it opposed to an older way. That's why it got changed. Absolutely, Audrey. What you got? You good right now? All right. Aaron?
Oh, hell no.
Hell no. Tammy, how's the foot?
Still attached.
Okay, good. There's no more questions. Thank you very much. And anytime you see me, if you need to stop and go, Tommy, I didn't quite get that, what you were talking about, can you elaborate? Not a problem. All right? Toodles.
Thank you.
You're welcome.
You're the best. Sorry. Wait.
It's Friday.